Okay, good afternoon, everyone. If someone with laptop can help me in admitting the new people who are joining, that would be appreciated. So, myself, I am Elsa Sharu Johnson. I'm a PMRF Research Fellow in NITT. So, I'll be taking the course Data Analytics with Python and Introduction to Machine Learning. And this is a course which is required of date, and it's of a huge value. If you have some knowledge about it, then you can have an upper hand when you're attending your campus placements. And so this can be a beneficial program for you. I'll just be giving you the basic introduction as well as the ML introduction part. So I hope you will be more interactive. I'll be seeing the inline calls also. So just I'll set up that now. Sorry. So yes, if you want to ask anything, you can put in the chat window, or you can unmute and ask it yourself. So if anything is fine. In between, if you want to interrupt and ask me a question, that you can do that also. Okay. So I'll just start with the presentation. I hope the screen is visible. And for the time being, I'll be switching off my video. So we'll be looking at data analytics with Python. So this will be the overview of what we'll be learning across the weeks. First one is Introduction to Data Science. After an introduction, we'll be looking at data operation with NumPy, then data manipulation with pandas. So after learning how to manipulate a given data, we'll be moving on to data visualization. We'll be learning about two main libraries, Matplotlib as well as Seaborn, both of which are used for data visualization. And then next one will be the introduction to exploratory data analysis. This is the most important stage in the data science. So here you'll be drawing out different insights from your data and visualizing them and drawing out some insight, some conclusions. Then after till the fifth step, we'll be doing some certain steps in the data science cycle. So after that, we'll be looking at certain available data sets, and we'll be doing EDA, which is exploratory data analysis. And thus the data analysis part will be over. Next, we'll be moving on to the machine learning part, where the data pre-processing is first looked on, and after pre-processing, we'll be seeing at different pre-processing steps for different types of problems in ML. Next, we'll be looking at classification problems, then regression problems, and a small mini project that you can do. So you can discuss what all to do. I'll be giving you certain links where you can follow, where you can collect data and do some projects. So this is the whole overview of the course. So today I'll be taking Introduction to Data Science. So if till this is clear, you can put an S in the chat window. And if my voice is clear, you can put that. I'll be waiting for your chats. I'm audible, right? Um, I'm continuing in the hope that everything is heard by you. So let's move on to the first one, Introduction to Data Science. Hey, please be having, you will be having a mobile with you, no, at least. You can just put an in-call message. Okay. So why I'm saying about data science? Why do you have to see this one? Okay. So according to the present sources available in the internet, you can see that the data is growing as at an exponential rate. Okay, the stored data, which is collected from different sources, is accumulating at a rate of 28 percentage of annual. It's having a 28 percentage annual growth rate, whereas the data analysis in the workforce is growing at a rate of 5.7 growth rate. Okay, so there is a huge shortage. You can see the number. There's a huge shortage of data analysts in the job market, and you can see the data analysts are there analyzing the ocean, analyzing pictures, the land, all walks of life. You can see a data analyst. So you being from the AAA department, you also have a role to play as a data scientist in many power generation industries and many other sectors in which you are having an upper hand to join the workforce. Okay, so you that data analysts and data scientists are needed in your area of specialization also. So data science, it's a new term. So Hector Garcia Molina, a professor in the Department of Computer Science and Electrical Engineering of Stanford University, has said that data science is a new term, but it's in the same sense as Columbus discovered the new continent some thousand years ago. So you can see the data science, it includes visualization, statistical modeling, statistical computing, data technology, data research, consulting, real world applications, scientific methods. All these things will include in data science. So data science, it is a multidisciplinary field. Okay, it uses scientific methods, processes, algorithms, systems. What it does is that it extracts knowledge from these different areas and insights. The data available to you might be structured or unstructured. We'll move on to the data types in the at the end of this lecture. Then it is a concept that will unify statistics, data analysis, machine learning, and the related methods in order to understand and analyze actual phenomena with data. Then it'll employ techniques and theories, which will include many fields like mathematics, statistics, computer science, and information science. So it is this field which includes um, theories from different fields. Okay, so statistics is included, but for in your case, statistics is okay because you have learned the basics of statistics in your um, basic mathematics courses that you have had till now. Then some computer science knowledge is required. Then information science. All these will be coming. So I'll just start with an example. So you people might be living in at home or in hostels, right? So when you want to get a simple breakfast, you don't see, for example, if you don't like the breakfast that is available to you, you'll be just thinking of having bread and butter or something else. Okay, so you are just going to a market or you're going to a supermarket or a grocery store, like even here. So you will be usually trying to access the bread as well as butter. Okay, so for example, you have gone to the grocery store, you have bought bread as well as butter. So can you give? and guess as what to the customer will buy next. Okay, so I mean these are two of the options. You'll need something else, right? So can you tell me what you'll be buying next? Okay, if people can answer in the chat window, that will be very good. Just put any of the options. I'll tell you. Sometimes you might have to buy milk. Sometimes you can buy jam. Can you put in the chat window what you'll be buying with them? I mean, you're already planning to buy bread and butter, bread and butter or bread and ghee for preparing a toast. Okay. So next, what you'll be buying? I'm waiting for your messages in the chat window. Okay. One have put milk. Anyone else? Okay. Any other options? Okay, I have got two responses now. We'll go with that. Okay. So right now, this present meeting, it's a group of 15 plus people. Okay. So in this group, I have got two options. Like one have given me milk, another have given me jam. Okay. So this might be the option for majority of you. Okay. Most of you might be saying milk. Some of you may be saying jam. So this is the um, what you say. These can be the major options that people will give when they first see bread and butter. Okay. So if the customer is interested like this, you can see that the shopkeeper who is in charge of placing the items in the shop, he can think of it, okay, of this buying pattern. So for increasing the sales, what he can do, he can just place a rack of milk and a rack of jam next to the bread and butter portion. Okay. So what can he do? I mean, if he places the items nearby these two things, then he can convince the customer that okay, you might need, I might need this also, I might need milk with that, so I can buy this also. So he can increase his sales when he does like that. So this is the similar thing which happens. Okay, next choice of the customer will be milk, or like some have said it can be jam. So this is a usual scenario. Okay, so if the shopkeeper understands this usual scenario, he can increase his sales by prompting the customers to buy the next thing also. Okay, so this is what happens when you use data. Okay, how can the shopkeeper know like this? Now right now I have asked for your opinion, what third object you will be buying. Okay, so you have said milk or jam. So this is data actually. You have given me a data according to your preferences. So if the shopkeeper is able to collect data from a huge number of people based on their history, on the history which they bought the things, he can predict like they might be interested in buying this also, and therefore he can do some things about it. Okay, so this is a basic example of how the recommender systems work, which is usually used by Amazon, Flipkart, Prime Video, Netflix, everything. Okay, so there also in Amazon site, when you're looking at buying a particular object, for example, you say when you're looking at buying a phone, okay, it's Amazon Prime Day today, so there'll be deals all over the place in the website. So you're looking at buying a phone, you'll be seeing customer have also viewed this, or after customers bought this after seeing this page, all those things will be there recommended for you. So how have they done this? There is not a single person who is sitting and deciding what you'll buy next. There is an AI algorithm, machine learning algorithm there, which had taken data from previous purchases, history of purchases, and have decided that the customers might be interested to do the might be interested to purchase another thing. Okay, so based on that, it is recommending to you. So this is one of the examples where data science is used. Now let's move on to data. How your data will be present. Okay, so data means they are raw or isolated facts from which required information is produced. Okay, so raw or isolated facts and information. What is the difference between raw facts and information? Can you tell me? You see, raw facts means you have just obtained it. Okay, so I'll be explaining with this an example. I'm just giving you this fact or raw fact. Okay, just like I'm giving you six chairs and table. Okay, so if I say six chairs and table, what will be coming to your mind? Okay, you'll be picturing six chairs and a table, but do you know where it is put? Okay, for example, six chairs and table can point to the situation of a dining room actually, if it's in the scenario of a home. Okay, and also six chairs can and table can also mean a conference room or a boardroom if it is in a company setup or an institutional setup. Okay, so I have just told you six chairs and a table. From this, can you infer whether it's I am referring to a home, dining room in a home, or whether I am referring to a boardroom? Okay, so the first thing, six chairs and a table that I've mentioned is like a raw fact. And when it's the stage where information can be produced, then I'll be saying like six chairs and table in a specific place. So if I mention that, then it will be becoming an information. Okay. Now facts can be recorded and they might have implicit meaning. Okay. So data scientists, they are a professional responsible for collecting, manipulating, analyzing, and interpreting data. Okay. So their main role will be to create actionable plans for companies and other organizations. Okay. So what they'll be doing is that they'll be given a set of data. Okay, they'll collect from it, they'll decide on it, they'll see what all parameters are useful, they'll see what are to be discarded, and they'll create some plans which can be used by their particular company. So that's why they are in huge demand right now. Okay, and this demand will go on to, it said that it will go on to 5 years or 10 years in the row. So you are in a prime stage to get these jobs, and you don't have to worry about, I mean, this is not your field since you are learning the in the electrical engineering department. You don't have to worry about that. I mean, you can go to your specific power sector itself, and you are needed there also because you have the domain knowledge in electrical engineering. Okay. Now, the traits of data scientists. If you are going to be a data scientist in one of the companies, then these are some of the traits that they'll be looking at you, or the people who are hiring you might be looking at. First one is statistical thinking. Okay, so you might be able to work with any given data. Okay, whether it be a data containing certain information, whether it be images, whether it be some speech data, something that is given, you should be able to work with it. Okay. Then you should be able to implement a toolbox full of techniques to make predictions and recommendation. And if you see some fishy behavior in the result, you should be able to ask, okay, For example, if you are getting a set of data, and in that data you are sensing some anomaly, so you should be able to see why that anomaly has happened. Okay, if your results are varying from the norm, then you should be able to ask questions, and you should be able to find out this is the particular reason that have led to the change in data. Okay, next is technical acumen. Okay, you should have a hacker spirit, and you should be up to date with the technology present. Okay, then you should be able to collaborate with a team. So you should be able to work as a team and lead people to move at the speed of the demand. So collaborating means that you can practice when you are doing your final year project itself. Okay, you have to, everyone of the team has to do some work, and everyone should be able to communicate what you're doing with your teammates. It's not just like, I mean, whoever is having strength in um, one of the aspect of your project can do one thing, but every teammate should be knowing it, and each person should be able to communicate each and everything. Okay, so you should have a collaborating mind. Next one is multi-model communication skills. So you should be able to study in context and translate a problem and its solutions to parties with varying background. Okay, so that means you should be able to use common ground, metaphor, skillful listening, and most importantly, storytelling. Okay, so why you should have multimodal communication skills? That means that when you are in a company, when you are going to, for example, when you are going to a power sector, then you are joining there you might be joining there as a data scientist. Okay, so your job is to find out, for example, your job is to find out what would be the failure rate of a particular equipment. Okay, or how much will be the predicted power um, consumption of a particular place. Okay, so you should be able to divert more power to that place. So you should be able to speak with the higher authorities of your company, like the general manager or a director of that particular company, and you should also be able to convey your findings. I mean, you might be analyzing some data of how a particular city have accessed the power in a particular time, and for example, a certain festival is coming up, you will analyze the last year's festival power consumption rates, and like that, I mean, you might be finding out whether a certain outage or overloading or something else, some problem, some failure can happen. Okay, so this findings, whatever you find from the data, you might be able to convince it, you should be able to convince it to your um, directors of the company, as well as you should be able to talk in layman terms or in technical terms also to your engineers, like engineers that are present in the company, as well as there might be technicians at the lower level. So you should be able to convey your findings to your technicians also. So you should be having a communication skill of speaking with your higher authorities, your managers. You should be able to speak with them and convey them and convince them. And you should also be having the technical acumen to speak in terms of the engineers and technicians present there. So that is meant by multi-modal communication skills. Next is curiosity. So it's an invaluable soft skill of learning why and how. Okay, so this can be triggered in the following cases. You might be asking for access to more data. You have data, only a little amount you have of data, and from that you can draw out some certain pattern in the data, but you need more data to see the correct result. Okay, then you might be curious to interview some users or draw out some survey, and then you should be trying something new in the next iteration. Okay, this iteration part will all come next. Then creativity, that provides the fuel for skillful communication. and it requires dedication and effort. And what you should be more creative is in the peculiar relationship with the word no. Okay, so thing is that you should be you should be waiting to tell the word no. Okay, you should be creative in telling like, wait, hold on, let me think. So that might be just a creative thinker. Okay, so not directly no, you should have a work around it. Now grit, that is another skill that is required. So it's an inner drive that pulls us over and keep us walking over obstacles and roadblocks. Now they should have the taste of tackling the new and the unknown. Okay. Next is data science reality. Okay, so this is something that is present right now. So what does this means is that machines, they can't learn arbitrary any task on their own as a human can. Okay, so from the different movies that are available, from the different science fiction movies that are available, data science currently has a hype. What means is that you might have seen many Marvel movies or some iRobot or those movies you have seen. You have seen robots which are capable of doing many different things. Like, I mean, they'll be able to think like a human, work, walk, everything they have shown. Okay, it's actually a hype. Actually, what? Why I'm saying it as a hype? Because there is no such algorithm or solution right now which can work best in all possible scenarios. Machines which are developed currently can't generalize its intelligence. Okay, what I mean is that um, I hope I'm audible. If not, can you just tell me?
Yes, Miss Audible.
Yes, okay. One of my devices got locked up, that's right. Okay, so what machine can't generalize its intelligence. Okay, you might be seeing robots that are currently developed. Even you might have seen Sophie, all those humanoid robots. So it's like what it does, it will accelerate the workflow, it can communicate with you, it can answer your questions. But what a human can do, I mean, a human can communicate, can make some different decisions, can do calculations, as well as based on different things. Human can play music, drive a car, then can walk, can play. All these things a human can do. Okay. But if you are making a machine for one thing, for example, you are making a machine for predicting, or for example, in Amazon recommender system, it's an AI there. It uses some machine learning and deep learning models. So can it do some other thing like drive a car? No, right? It can. You may. I mean, like it can just um, recommend things for you. Okay. It can't have another thing like it can't play music, it can't generate music. We have just set up that particular program for having some specific operation. Okay, I hope you understood. So, if you are developing a particular thing, I mean, if you are developing a self driving car example, that particular AI system can't predict what is the stock market price, or it can't predict how much the weather, how much changes in the weather will be. Okay, but a human can drive the car and human can see the weather outside and can see whether it's going to rain or not. Okay, so it can't. The current limitation of machines is that it can't generalize. Okay, so data science has particular hype. It will improve in the coming years. Particularly, COVID has done, it has accelerated the technology of data science actually. So many new applications have come up in this particular period. Okay, now these are the problems solved by data science actually: classification, regression, anomaly detection, recommendation, clustering, reinforcement. All these are the different types. Okay. So this is what I'm saying. One program which is developed for classifying can't do a regression problem. Okay. For example, classifying, I'll tell you, seeing seeing different images which are having mask, with people wearing mask or not wearing mask. That particular program can't predict the car selling prices. Okay, so it's developed for a particular problem only. Okay, now uh, I'll tell you an important um, example. Okay, you can just search it with the using the Target company. Okay, Target is a big box store company. Okay, I'll be sharing the link later. Okay, so this is a particular company. Okay, it's working out of US, and they in the year 2012. It's an old story. So what this company did is that they have figured out a way to data mine actually. Okay, so you can read more. I'll read more about this. I'll just tell you what happened there. So Target started collecting data from its customers. Okay, so usually when you go to a store, you'll be giving, I mean, while paying, you'll be giving your phone number and maybe your card information or GPay or any other information. So, like that, in the year 2012, Target used to collect data from its customers, and what all they collected was their age, name, and their credit card information, and what all they bought. Okay, so and they have certain um, programs also, like in, I mean, for example, in More or Reliance, you have Reliance One customer something, and More membership. You will have membership. No, like that's this Target also are have looked at their data, and what they did was that they assigned each customer a guest ID and took their credit card name and email address. Okay. Also, they collected the name of people who have signed up for certain registries. So in this particular case, they had the option of registering for a baby registry. Okay, so this will include ladies who are trying to buy in the coming months. So they are expecting, so they'll be trying to buy certain baby related items. So they'll be looking for certain discounts and all. Okay, so Target looked at this history. They found out that when the ladies started buying more cotton balls, sanitary solutions, then certain unscented lotions. I mean, usually they might be buying scented lotions. In the period when they are registering for the baby registry, they'll be going after unscented things. So they found out that those who are in nearby their date of expected delivery date, they'll be buying these things frequently. Okay, they'll be buying certain baby items also, like diapers and all. So looking at that, they try to figure out which all customers might be um, going to buy or might be in their gestational period. Okay, expecting period. Okay, so what happened was that they did a prediction score for people who might be pregnant, and based on the score, if the score was high, this particular company began sending brochures and coupons and all to those particular people whose pregnancy prediction score was high. Okay, so what happened was that in Minneapolis, uh, a certain day, an angry man came to that office store in Minneapolis in US, and he demanded to see the manager there of Target company. So what he did, he was very angry and stormed at the manager and said, "What are you trying to do? Why are you sending my teenage girl promotions and codes on baby diapers, baby lotions, and unscented lotions and all? Are you trying to get my girl pregnant?" Okay, like that, this person came and asked. So the manager got very confused and he was astonished why this happened. Okay, so the people, they might not be very. I mean, this is a new thing only. The prediction score they have done implemented newly, and so this person was very astonished, and the manager apologized because he is also not aware of this program much. So the manager apologized and then called again a few days later to apologize again. Okay, so they have a nice customer service. So in the phone, the when the manager called after a few days, on the phone that particular father was, I mean, he was a little calm, and he said he had a talk with his daughter, and it turns out that there have been some activities in my house that I haven't been completely aware of. That's what he said. That now, okay, so he didn't know that his daughter was expecting. Okay, so she's due in some coming months. So he apologized to that manager. So what Target discovered that it creeped people out that the company knew about their pregnancies in advance, more in advance than the family members knew about it. Okay, so this is a thing in how the data is very intrusive in your life. So now we know that very data protection laws have come up. So you might be, whenever you are visiting a site, you'll be seeing that data protection user agreement, and you can select whatever data that you are sharing with the particular website. You can opt for just sharing the necessary information, strictly necessary cookies, and you can avoid everything. So this is a way in which the data is currently working. Okay, it is collecting a huge amount of information from you. Okay, so now there are laws of what to see, what all things you can share and what all things the companies can see, and it is a highly debated thing also. Okay, so now go to the problems that are solved by data science. The first one is classification. So in classification, just you can see the image there. You might have past stable data as a cat or a dog, and there might be a model. You will train this model to predict whether it's a cat or a dog. So this is a supervised learning concept. So supervised, as you all know, you might be having a label. Okay, you might having a set of data, and based on the different features, you might be having label for the data also. So based on this label, your model will be trained, and when a new data is given, then the prediction will happen, and you will give an output seeing whether it's a cat or a dog. Okay, next type is regression. Okay, regression means it's also methods that allow us to predict a continuous outcome variable and based on the value of one or multiple predicted variables. So this is also a supervised learning technique. And one of the examples is a car price prediction. So you all know the car prices will depend on the mileage, the year of the manufacture of that particular model, then the fuel type used, whether it's a petrol or diesel engine or a hybrid engine, and the body type of the car, like whether it's a sedan, hatchback, SUV, or micro SUV, like that. So its prices might vary based on these different things. So these are known as the predicted variables, and the outcome of this particular problem will be the price of the car. Okay, so that is a regression problem. Now next is anomaly detection. So it refers to the identification of anomalous data or outliers. Okay, so this can be observed when you do a particular transaction. Okay, so for example, you are a person who uses about 1,000 rupees each month. Okay, you don't draw much um, amount from your ATM in a month. Okay, so suddenly, for example, if you wanted to apply for a course abroad, or if you want if you're just trying for some higher studies or something, you should do a transaction in dollars actually. Okay, so usually you need an credit card for that. So but usually each month your credit card spending was about 1,000 only, as I said earlier. Now when you try to make a transaction like that in another currency, you might have seen, or for another example will be you're trying to buy some jewelry or something, going for some shops, jewelry shops or something, or you're doing some high purchase. Okay, you might get an alert that you have accessed this particular site, or you have accessed your card for doing this purchase. If not done by you, please alert immediately, like that. Okay, so this is an anomaly actually. You are a person who don't spend more than 1,000 in a month. So when the bank servers, the AI algorithm in the bank servers detect that there is an anomaly detected in your spending, it will alert you. Okay. So this is how the fraud detection in banks work. Okay. So observations that differ majorly from the rest of the data are extracted and used to find out whether it's a fraud. Okay. Next one is recommendation. You know this very well. So this is how you can see different recommendation of movies in Netflix, Prime Video, YouTube, Spotify, etc. Okay, so the offering of relevant suggestion to users based on the product or service. Okay. Now next one is clustering. Clustering means the technique that involves grouping of data points with similar properties. For example, in clustering, the first one, this is a basket of some different objects. So by color, if you are clustering, the first thing. By shape, you can cluster it as a regular and irregular shapes. And by size, small and big. Okay. Now, next is reinforcement learning. So reinforcement means software agents ought to take certain actions in an environment in order to maximize the notion of cumulative reward. Okay, so this is what happens in self-driving cars. This is what is being developed there. So I'll just show you a video. It's by 2 Minute Papers actually for OpenAI. I'll just share that tab. If you are not hearing the audio, you just alert me by unmuting your mic. Okay, I'll just play this now.
Fahir. In this project, OpenAI built a hide-and-seek game for their AI agents to play. While we look at the exact rules here, I will note that the goal of the project was to pit two AI teams against each other and hopefully see some interesting emergent behaviors. And boy, did they do some crazy stuff. The coolest part is that the two teams compete against each other, and whenever one team discovers a new strategy, the other one has to adapt. Kind of like an arms race situation, and it also resembles generative adversarial networks a little. And the results are magnificent, amusing, weird. You'll see in a moment. These agents learned from previous experiences, and to the surprise of no one, for the first few million rounds, we start out with pandemonium.
So I hope you can hear. If you can't hear, you just alert me, okay? Or put a message. Is it audible?
Yes, Miss Audible.
Okay, I'll play this.
Everyone just running around aimlessly. Without proper strategy and semi-random movements, the sequence seekers are favored and hence win the majority of the games. Nothing to see here. Then, over time, the hiders learn to lock out the seekers by blocking the doors off with these boxes and started winning consistently. I think the coolest part about this is that the map was deliberately designed by the OpenAI scientists in a way that the hiders can only succeed through collaboration. They cannot win alone, and hence they are forced to learn to work together, which they did quite well.
Okay, now. So what they have done is they have just learned to collaborate with each other. The blue ones are the hiders, the red ones are the seekers, and they have learned to use these boxes to prevent the seekers from finding them. Okay, so you just observe what happened. Okay, something weird happened now. You see how the seekers then work. Okay.
But then something happened. Did you notice this pointy, doorstop shaped object? Are you thinking what I'm thinking? Well, probably. And not only that, but about 10 million rounds later, the AI also discovered that it can be pushed near a wall and be used as a ramp, and ta-da! Got him. The seeker started winning more again. So, the ball is now back on the court of the hiders. Can you defend this? If so, how? Well, these resourceful little critters learned that since there is a little time at the start of the game when the seekers are frozen, apparently during this time they cannot see them, so why not just sneak out, steal the ramp, and lock it away from them? Absolutely.
So you see, no? About that they could use this ramp and to come inside. So after 10 million rounds, what the hiders did that they found that that is a particular time at the start of the game to bring that ramp inside. So they brought it inside now, and then they locked it. So the hiders are not able to do that again. Okay, so this is how
Incredible.
the
Look at
game
those
has
happy
learned.
eyes as they are carrying that ramp. And you think it all ends here? No. Not even close. It gets weirder. Much weirder. When playing a different map, the seeker has noticed that it can use a ramp to climb on the top of a box, and this happens. Do you think couch surfing is cool? Give me a break. This is box surfing. And the scientists were quite surprised by this move, as this was one of the first cases where the seeker AI seems to have broken the game. What happens here is that the physics system is coded in a way that they are able to move around by exerting force on themselves, but there is no additional check whether they are on the floor or not, because who in their right mind would think about that? As a result,
Okay, what happened here? The ones who have coded this game haven't taken into account that whether the seekers are on the ground or they are on top of something. Okay, so that height parameter haven't been given there. So as a result, what they did was that they moved on top of something and used that to come and go inside the and find the hider actually. Okay.
something that shouldn't ever happen does happen here. And we are still not done yet. This paper just keeps on giving. A few 100 million rounds later, the hiders learned to separate all the ramps from the boxes. Dear fellow scholars, this is proper box surfing defense. Then, lock down the remaining tools and build a shelter. Note how well rehearsed and executed this strategy is. There is not a second of time left until the seekers take off. I also love this cheeky move where they set up the shelter right next to the seekers, and I almost feel like they are saying, yeah, see this here? There is not a single thing you can do about it. In a few isolated cases, other
So you can search this one later. I'll just share the link at the end also. So this is how the OpenAI, it's a game which plays hide and seek. So this is one of the example of reinforcement learning. Okay. Now, So we'll just look at the industries which are involved in data science. So first one is banking and finance. I have already explained this. In banking, there's the fraud detection and prevention, then customer segmentation. I mean, that means based on your purchase pattern and based on your deposits in your bank, they'll be segmenting you to different type of customers. Okay, so this can be observed in the cards that you get also, the credit card or debit card. There is classic, platinum, gold, diamond, all those different things are there. So this is based on customer segmentation. Okay, then risk management, whether, I mean, if you are applying for a loan or anything, whether you'll be able to pay that out based on your previous um, borrowings and all. Then credit finance factoring, credit default risk assessment. These are all the different applications where banking and finance uses data science. Now healthcare. Healthcare is a very important area where it is used right now. So healthcare detection of a disease, genetic analysis, then in the detection of a disease, this was particularly important when COVID is there. So it will be used to know well how this disease progresses, what is the severity of the disease, how it can spread through a place. So many data scientists and ML engineers were employing their models to find out how fast it will spread, how is the predicted spread. I mean, we also have learned about some predictions like in this particular month it will be at the peak and all. You have got predictions and all. Some cases, in most of the cases it had worked, in some cases it has not worked, so it is improving only. Okay. Now genetics, for genetics analysis, you can say that you yourself are terabytes of information. So a single DNA strand, there is about 350 GB of data. So we are all walking databases. So in that, I mean, you can get some data, you can see whether a particular disease is possible. You have a particular, I mean, um, chance of developing a disease or not. Then post-surgery survival analysis. So based on the data of previous surgery patients, you might be looking at after the surgery whether there is a chance that you'll be surviving. Okay. Then epidemic forecasting and control. That is, we have seen it already. Then eye health prediction. So Google itself has done a diabetic retinopathy program, and it has predicted for about a 95% accuracy. Okay, based on eye images. Next is retail and commerce. So this is where the Amazon, Flipkart, all those people work. So they want market basket analysis, then supply chain profit prediction, sales forecasting, prediction of cart abandonment, customer sentiment analysis. So these all like cart abandonment, you can that is employed very correctly and beautifully with Amazon, or you can say Mintra also. So you, for example, what I can tell you is that in certain deals and all in Amazon and all, you might be saying that this much 15 minutes for checkout or 10 minutes and 9 minutes to check out for this deal to expire or something. You might have seen that. Okay. So this is something prompting you to buy that particular object and preventing you from leaving it in the cart. Okay, something earlier when people used to shop in Amazon, they had a tendency like putting things in the cart, adding that to the cart and leaving it. Okay, so they analyzed this one. They found that some people are likely to put things in their cart but may not end up buying them. So they brought out certain strategies, like they brought out like there is a deal on this product, and you have 10 minutes to acquire that deal. Okay, so this is something they have done for preventing cart abandonment. And the customer sentiment analysis is there. So in customer sentiment analysis, it's like seeing what is the sentiment. Okay, whether they buy this thing in this particular time. Okay, based on that, They can put certain deals or reduce its price or increase its price, so on. Okay. Now in telecommunications, there it's used for customer churn prediction, then network congestion detection, then identification of network quality, recommendation of new services. So one example will be like when you are in a particular area, if your phone network selection is in auto mode, based on the network which is available there, either 3G, 4G, or 5G, you are not 5G, either 3G or 4G right now. So your phone will be switching in between the different carriers available. Okay, so that is one of the things that is there in your phones. Then to optimally select which network will give you the maximum coverage. Okay. Next one is energy and utilities. So you might be more interested in this area. So this is the first one, is preventive equipment maintenance. So this is a very particular research area. So this, what it done is that it's used to avoid the downtime. So in most of the cases in different industries, if you can reduce the downtime, about 75% of the lot can be reduced. Okay. So if you have certain data about when your particular equipment is likely to have a failure, okay, then you can keep it for maintenance. Okay, then you can ensure that there's no downtime for your company. That's one of the cases. Then smart grid security and theft detection. So this has been implemented in some parts of India as well. There is one news about being implemented in Bihar. But what happened is that people, so it's used for theft detection of energy, okay, detection. But what happened there was that it's a joke was played on the authorities itself. Like what happened was that the equipment used to detect the theft itself was stolen. Okay, so wasn't able to implement this correctly there, but still it's now improving. Now then the real-time customer billing, okay, and outage detection and prediction. So right now you might be getting messages in your case from KCB like you'll be having a power cut from this time to this time to your subscriber mobile number, and based on that it's keeping the time also. Okay, I mean, so some prediction is done to see when or what time a particular repair work might take. Okay, now failure probability modeling. So this is particularly important in single track lines for trains running. So if they have a backup engine or something, they can reduce the failure. Okay. Now in manufacturing, demand forecasting. So how the demand for that particular object is likely to change, and based on that, manufacturing can be increased or decreased. Prescription on fault detection and in assembly lines and all. Then supply chain risk analysis, quality assurance, then warranty analysis. So that is enough information had already been collected to say how much years a particular device will last. So if you see a particular home appliance, and if you are getting a warranty of about 1 year or 2 year, how they have selected is like they have already seen data of how much years their particular device is used to is expected to work, and based on the data that is available they'll be fixing the warranty years. Okay, so when they give a product to you, they have already tested and you have got assurance that their particular product will last without any problems for 2 years. Then they'll be fixing the warranty years as to for your particular product. Okay. Now, next is data science life cycle. Okay, so these are the different steps in a data science life cycle. First one is business understanding. Okay, so business understanding means finding out the relevant info at um, seeing which particular data is there to be collected. Okay, so that is the first step. Okay, ask relevant questions about the problem, define objectives that need to be tackled, and the objectives that are defined should be very specific and clear. Okay, so this particular stage is where you have to convince your understanding to your um, bosses or authorities. You are just finding where this can be done. Okay, now after that, next one is data mining. Okay, so in the first step, you have identified a particular problem, and based on that problem, you'll be doing data mining. So data mining means gather and scrape the data necessary for the project. So in that thing, collection of data. Okay, so when some objective is understood, then you should have certain aspects of those problem to be collected. Okay, now there are different common databases which are given like SQL, Hadoop, etc. And how you are analyzing the data currently is like in terms of .csv or .xlsx files. Okay. Now next one will be data cleaning actually. So data cleaning means that is the third step. So in data cleaning, what we'll be doing is that look out for all the problems in the data and finding out the different challenges. So this particular step will include different things like missing data, duplicity, inconsistent type, irrelevant data, outliers, formatting. Okay, so we'll see one by each of these one by one. So for explaining this, I have just taken a biomedical data based on diabetes actually. So here in this data, I've just listed out the different features which were collected like ID, patient number, gender of the patient, age, then their urea levels, HbA1c levels, cholesterol levels, LDL, BMI, and class. This class this class says whether the person is diabetic or not. Okay, so N refers to not diabetic, and Y refers to diabetic class. Okay, so you can see that I have marked some certain cells in red actually. Okay, so these cells are not having data. Okay, so data sets not a number data. Okay, so what happened might have been like when the data was collected, some were missed out. Okay, so this missing data have to be dealt with before you do some analysis on the data. Next one, next one will be like duplicity. Okay, so duplicity will mean that some of the entries might be duplicated. Here I have marked them as orange cells. Okay, so in this particular data, these cells have been duplicated. So duplicate cells need to be removed. Okay, it can be either in rows or columns. Okay, next is inconsistent data. So some data might have inconsistent data types. So here in this case, BMI is coming as a string data. Okay, numbers given within inverted commas can be taken as a string. Okay, so here what happened is that it is actually numeric data. Okay, BMI values should be numbers, but due to some error that was happened, it is coming as a string data. So this is particular example of inconsistent data type. So we have to change its data type to a numeric data type before analysis. Next one is irrelevant. So data which has no use at the prediction. So for example, we are trying to predict whether a person is diabetic or not. So in that case, there is no relevance for the ID or the patient number. So I have just marked them as purple. So before analysis, we can just omit these two columns. It's not required. Okay. Whether a person is diabetic or not won't depend on your patient number or ID. Okay. Now the outliers. Outliers means that data that goes beyond the permissible values. So this particular column, you can see that in HbA1c. HbA1c is a cumulative um, value of 3 months actually. Okay, so it's used to find whether you are diabetic or not. So if your value is below 5.6, then you are not diabetic. 5.6 to 6.5, so that range is there. Okay, so in this range you can say that, I mean, the highest value of this won't cross about 13 or anything. So you can see numbers like 120, 110 here. Okay, so the case that have happened might be like some people by mistake might have put fasting glucose values in the HbA1c column. Okay, so because of that, we have got data which has gone outside the value of the HbA1c. So this might have should be removed or should use certain data pre-processing techniques to come bring it to the permissible values. Okay, and in some cases you might have to avoid the data completely also. Okay, this we'll see later in the pre-processing stage of data in later lectures. Now, formatting issues with the data have to be prevented. For example, in the gender column, here there is capital F, small f, capital M, and a small n. Okay, so if you look at this data, actually there are only two classes. Okay, only two classes, either female or male or in this particular data. But if the machine reads this particular data, it will be giving out like four classes: one for capital FNM, I mean two for capital FNM, and two for small FNM. So where, where there should be two classes, it will be showing four classes. So that is a formatting issue. So first you have to change it either to uppercase or lowercase before we do something with the data. Similarly, in the class case also, n, capital N and small n, capital Y and small y is present. This also have to be taken care of. So after this, after data cleaning, data exploration is there. So in data exploration, meaning drawing out meaningful insights from the data, then discover patterns, spot anomalies, form some hypothesis about the data. I mean, you have collected certain data. Based on that, you will do some exploration. This is the step before you do the feature engineering. Okay. So feature engineering, as you can see the figure there, you have a large set of data in particular columns. So from these, you should construct meaningful features. Then some important features if present, you have to select them, and then data splitting and preparation. All these are the steps. Okay. Then you will plan it out and you'll construct some meaningful features and graphs from them. Okay. Then feature creation, just an example, like new feature cells can be generated that will add meaning to the existing features. For example, there is a product and a color column, and in that color, red, green, and blue is present. Okay, so you can change it to product numbers, and then you can see different features like red, green, and blue. Whenever a product is red, you can put one there, and similarly for the rest of the cases. So this is feature creation. Earlier there was one feature named as color. Now three more features have been created from that, named as red, green, and blue, to create more meaning to the data. So after that, after the data exploration and feature engineering, then we'll have predictive modeling. Okay, so predictive modeling means we'll we'll train different machine learning models and evaluate the performance and fine tune our key findings. So this is the time where we use the machines to do certain learning tasks. Okay. Now after learning, you might have to present your findings to your peers or stakeholders or your higher authorities. Okay, so explanation or communication of the findings can be done using plots and interactive visualization. So this will be to act and deploy findings in the real world. Okay, so these are the different steps. Okay, till this one, these are the different steps of data science life cycle. Okay, now Next one will be the different types of data. So we'll see what all data will be available when you go for certain problems. Okay, the types of data are divided into qualitative data as well as quantitative data. The qualitative is also known as categorical data, and quantitative is known as continuous data. Okay, so then the qualitative will can get divided into nominal data as well as ordinal data. So we'll see each of the things one by one. So nominal data means data related to names. For example, gender, it can be women or men. Hair color can be blonde, brown or brunette. And housing style, ranch, modernist art. Then car type can be sedan, SUV or hatchback. Then marital status, married, single or widowed. Okay, so in this type of data that there is some categories. Okay, how it's different from the other one is that this one doesn't have a particular order. Okay, so gender, if you when you're saying, you can say it as women or men, or you can also say as men or women. Okay, there is no particular rank for that. Okay, but the other one, ordinal data, sorry. So in ordinal data, data will have particular meaningful order or ranking. For example, in a competition, the first, second, or third person that will be having a particular order. Excuse me. Then economic status, low, medium, or high. Letter grades ABC. So this is data which has some order. Okay. Then customer level of satisfaction, satisfied, neutral, dissatisfied. So can you say some example? Can you say some example of ordinal data where you'll find in Amazon, Flipkart, or anything? Something like your product might be rated. How will you be rated usually? You can put in the chat window, or you can unmute your mic and tell me.
പക്ഷെ അത് നമ്മൾ ഫിൽട്ടർ ചെയ്യുന്നതിന്റെ ആണോ നമ്മൾ ഓർഡർ?
Filter അല്ലാതെ വേറെ എന്തെങ്കിലും? It's like you can see when you look at a product, you can see.
നമ്മൾ കമ്പയർ ചെയ്യുന്നതാണോ രണ്ട് പ്രൊഡക്ട്സ് തമ്മിൽ?
In the comparison itself, you'll be having some. When you're buying, what all you look actually. When you're buying a product, what all you look. How will you get convinced to buy a product? Okay, quality. How you'll know the quality? You have been bought it. Okay, so what you'll see. One person has message quality. How you'll see the quality? An important thing you'll be looking now. You'll be looking at some previous things actually. You all know
പക്ഷെ
this actually.
റിവ്യൂസും റേറ്റിംഗ്സും ഒക്കെയോ?
Yes. That one itself. So the ratings, no, you'll get a 5-star, no. The ratings, the fifth, if the product has 5-star, it is the highest quality level product. I mean, based on the rating. Okay. Now the 4-star comes below that, 3-star comes below that. So that is a particular data which has a ordinal value. Okay, that is the ordinal data. Okay, it has a particular rank. Now, if I am just another example is like I am collecting data of some students in a class. Okay, so for a particular subject they might be receiving outstanding. So in your case, I think S is the highest rate, no? So outstanding grade is S. After that, A, B, C comes like that, right? Or O is the one. I'm not sure. Anyway, like
It's OS.
O is okay. So that is the highest one. So looking at the data itself, you will see that it is having a particular rank. Okay. So this type of data is ordinal. But the same thing, I mean, these two are categorical only. But in nominal data, there is no particular order. Okay. So there is no ranking. I mean, if you say that if the ethnicity, if some particular data you are collecting about a certain disease and you are seeing whether how it affects certain ethnicities, you will be having ethnicities as Hispanic or Asian, but there is no particular order for that or ranking for that. Okay. If you have a column like gender column, there is no order for that. You won't rank them. Okay. So this is how the nominal data and ordinal data varies. Okay. Now next one is numeric data. Okay, so numeric data itself it's divided into interval and ratio scale. Okay, so for example, this one is quantitative in nature with a non-inherent 0 point. Okay, for example, in the case of temperature. Okay, let's say today's temperature. I'm living in a very cold area. Just assuming. So today's temperature was about 0 degrees Celsius. Okay, now, yesterday's temperature, when I looked it was about minus 4 degrees Celsius. Okay, and it's predicted that tomorrow's temperature will be around 2 degrees Celsius. Okay, so in this particular type of data, interval scale data, you can't tell that yesterday or today is 4 times hotter than yesterday. Can you tell that? I mean, yesterday's temperature was minus 4 degrees Celsius. Today it is 0 degrees Celsius. But based on that, you can't tell that it's 4 times hotter than yesterday. You can just say that the difference between yesterday's and today's temperature is 4 degrees Celsius. Okay. So here it allows the difference between values. Okay. That is interval scaled numerical data. But for the next type, ratio scaled numeric data, this is also quantitative in nature. Okay. But it has an inherent 0 point. For example, this is speedometer in a car, okay? So its value can be positive 0 or negative, but it's measured on the scale of equal units. Okay. So when you're starting the car, it might be in 0, then you will accelerate it some times and you will reach about 40 or 60. So you can quantify it with the ratio. Okay. You can say that it's this much times faster than the previous speed. Okay. So that is the ratio scale data. Okay. Now, next we have just looked at the different types of data. Now we'll look at data, how they are structured. Okay, so on data structures, they are divided as structured data, semi-structured, unstructured, graph data, and streaming data. So you need to know different types of data and their structures before you do some analysis. So here you can see that first one is structured data. So structured data means there is a well-defined structure and a consistent order. Okay. So in this figure, you can see that I'm pointing my cursor at this particular block. In Python terms, I mean since its indexing starts from 0, you can access that particular cell by using the row number 0, 1, 2. 2 is the row number and the column number is 1. So if you say 2 comma 1, then I'll be accessing that particular cell. Okay. So in structured data, a particular cell or particular value can be accessed easily. Just you have to mention the row number and the column number. Okay. But look at unstructured data. Is there any way to say or access a particular data from that? So that doesn't have a structure. It's not divided into rows and columns. It's randomly structured. Okay. For semi-structured data, it's coming in between the structured one and an unstructured one. So some columns might be having some structure, some might not be having some structure. So when you are analyzing some things, you'll come across all these three different types. Okay. So in structured data, example is tabular data such as Excel. For semi-structured, it has some structure, some organizational properties are present, which makes it easier to analyze, like example JSON data. Then for unstructured data, you don't have a structure for that. Usually it will consist of text or images or videos, and it's not easily searchable also. You can't go through the, if you have some image data, you can't access it by giving some row number or column number or anything. It's very unstructured. Okay. Now next type is graph data. So graph data means nodes, edges are there and properties are used to represent and store data. Examples are LinkedIn connections and Neo4j connections. So if you see, I mean, in LinkedIn itself, you might be having an account, and using graph data, you can find out how you are connected with your different other connections. And you for example, you have a third party connection. For those who are using LinkedIn, you can see that you might be, I mean, you can see how you are related to some other person. Okay, so you'll be having direct connections, some members you'll be having, and who are your connections, and then from their connections you'll be related to some other people. Okay, so like this graph data, they'll be drawing out to see how you are related to some other person. Okay, so nodes and edges are there to represent how that relation is coming. Okay, that is graph type of data. And finally, the next one is streaming data. Okay, so in streaming data, it's continuously generated by different sources. They require continuous processing and cannot be accessed all at once. For example, you can see, in App Store and all, you can get different apps to see the speed test of the network, then YouTube, and the meeting right now I'm doing on Google Meet. These are all streaming data. Okay, so if you want to access something, for example, live stream analysis of a camera in parking lot, or you might have seen mask detection stream data that has been used in China and all. So those are all streaming data, and from that data you'll be finding out whether a person is wearing a mask or not. Okay, now these are the different types of data structures. Now this is the introduction to the basics of the data science. Okay, so I just want to show you a different video on machine learning visual inspection in an assembly line. So you can just watch this video now.
Visual quality inspection operates.
Visual quality inspection based on machine learning techniques is used for the defect and mismatch assessment. It can be used for such industries as retail, manufacturing, airport baggage screening, food industry, medicine, and etc.
Let's see how it works. Recent progress in computer vision makes it possible to use advanced deep learning technologies for visual inspection. Images captured by a camera are processed by a neural network, which is trained to detect and localize the defect. Once the visual inspection system is confident about where the problem is, it takes predefined actions, like sending a notification or executing other operations. What are the possibilities of visual inspection for business? Let's imagine that we are producing sunflower oil. Even during production, bottles can be damaged that may result in additional costs and trouble during transportation. Thus, visual inspection based on the computer vision model detects the mismatch and notifies us in real time so that defective objects can be excluded before they reach the final packaging stage. Another example, different working areas on a plant require workers to have certain equipment to be worn, like helmets, gloves, or boots. The neural network is able to analyze stream from monitoring cameras and notify if anyone working in the areas violates the requirements for this certain zone. What is required for implementation?
A correctly trained neural network ensures the high accuracy of the quality management system. The network can be trained with many images of different objects. The network architecture depends on the task: image classification, object detection, or semantic segmentation. Depending on how
This is how the data science helps. So I'll just those who are in the meeting, I just want you to show what you have to do for next week demo. So I have this class formed actually, Introduction to Data Analytics and ML. So this is the class I have formed, and here I can paste this code in the WhatsApp itself. So here I'll be posting different things, and in the first uh, mm, classwork, I have included some things. Okay, so how you can access is that, I mean, in our future classes, we'll be using Google Colab network. Okay, so Google Colab, what you have to do is you just go to Google. Wait, I'll share this tab, and then you have to type Google Co Laboratory. Okay, and if for persons who haven't used this, okay, so welcome to Co Laboratory. It will show, and if you have certain things done there, you can see that. Or if you want a new notebook, you should press New Notebook, and they'll show you certain things that you have to do. Okay, like coming. So it will show you an entitled notebook. This is known as a Jupyter notebook actually. Okay, so this is a Colab notebook. Its extension is IPYNT. Okay, so similarly, I have given in that classwork two files actually. Okay, the first one is Python Basics PMRF Lecture 1, and next one is Python Basics PMRF Lecture 2. So here you just have to log in with your Gmail ID. Okay, so I'll just open that and show you what I have done there. So this is for people who haven't worked with Python. Okay, so just I have listed the main basic things. So just starting from how the introduction is there, then comments in Python. So how you have to see. So just I'll just show you, just like what you see. So just the indentation, for indentation, I have given one thing. Okay, what you have to do is that you just want to run this one. I have given you the description, and you just run this cell and see what is happening. So before running, you can see here connecting, allocating, and on. Okay, so you need to ensure that your particular Collabo3 notebook is connected. Okay, if it's connected, it will show you a tick and a RAM allocation and a disk allocation. Okay, so this is one thing that you can use in your laptop, as well as you can use it from your mobile itself. Okay, so in the next classes, whenever I am explaining something, you can yourself in real time do this particular program. If you want to try out something new, you can do it there itself, and you can run it there. Okay, it's very easy. So you might already have worked with embedded C or C++ or anything in your previous semester. So those who have done it will be very easy. So it's intended assignment things, everything is very easy actually compared to others. So I have included these two, Python Basics Lecture 1 and Python Basics Lecture 2. So this class code I'll be sharing. You in the coming 1 week, whenever you get time, you go through these lectures and go through these notebooks actually. And if you have any doubts, or those who can't follow some certain portions, you can message in the group given, or you can personally message me, and then we'll see whether some basic Python class should be taken. Otherwise, I'll be sharing going with the next data analysis, data manipulation, and data analysis with NumPy. Okay, that is the next advanced part. So this 1 week you can go through the basics files. Okay, so that's all for today. I hope you have understood what I have shared. Okay, and this class code I'll be sharing very soon. So have a nice rest of the day. Thank you for joining. If you have any doubts, you can just ask me now. Okay, so we'll see you next week. Okay, then bye.